louder than normal.
Oh, we're just quieter.
Dissociation constants. Have you ever heard of a dissociation constant? That means KC. It means the equilibrium expression when something breaks apart. Easy enough. It's a tiny bit different because it's for dissociation, not really a chemical reaction. But it doesn't matter. Like it's all the same math. So here we go. 4. Just a general acid. We would have HA. When you go to college, they use HA a ton. Like they hardly ever talk about a specific acid. H just means hydrogen, and A just means the anion of whatever that acid is. So whatever general acid plus water dissociates into the anion, which we have a name for, we call it the conjugate phase. Good job.
Oh, we're supposed to say something.
Okay. Rest in that, right? Is that you? Yeah. And then it makes H3O plus or the conjugate acid. Okay, these are my products. Since those are my products, they end up over here. H3O plus times A minus over HA.
So H3O is considered aqueous, even though it's pretty much just water with an extra negative.
Yeah.
I'm not sure how I feel about that.
Chemistry doesn't care about your feelings.
That's true.
All right. Now, my friend. Okay. Oh no. Oh yeah, that same problem as the other day. All right, here you go. You can simplify this just to be H plus times A minus, if you want. H3O plus and H plus is the same thing in my heart. And I don't have to work that. That's a good time. Doesn't matter. I don't care about chemistry. Oh, is that my calculator that I should calculate off?
Yeah, it is.
Okay. You were the last one.
I believe it.
Some people left it here when they were. Okay, so here we go. This is always the same. All right, so the greater the value of Ka, the stronger the acid. Now, if we understand what this means again, like what Ka, I guess I didn't call it that, did I? Kc is Ka.
Is there any exceptions to that?
No, not really. Ka just means we're doing Kc for an acid. You know that? So it's the same math, same idea, and same everything. But if we do it for an acid, we specifically call it Ka. All right, so I sort of just like to leave it there. It says that. All right, so Ka will always be the concentration of H plus and the anion over the concentration of HA. Yeah. So if it has a greater value, that means my Ka equals a big number over my small number, right? Big means the products are large, which means it dissociated well, which makes it a strong acid. Now, you definitely will see questions like this where it just gives you a list of acids and their Kas, and it asks which one is the strongest acid. So this isn't very hard because they're listed in order. These are all weak acids, by the way. You don't usually find Ka for a strong acid because this bottom denominator is 0. So yes, these are all weak, but this is the strongest of the weak ones. Now, people often get this one wrong because they suck at math. A -10 is a much smaller number than a -4, right?
We can just get away with just looking at the exponents for the most part.
Yeah, like these two have the same exponent, so then you have to look at the bigger one. But yeah, the exponent is 99% of the time we see the right. Okay, so the bigger the Ka, and they're always gonna be small numbers, but they're comparable, the bigger, the stronger the acid. And once again, you should definitely understand, we do not take the Ka of strong acids or strong bases, because they're 100% ionized, which means the denominator would be. That is once I created a black hole. All right. Oh, yes.
Ice table.
Ice tables, yes.
For finding the constant per base, would that just be KB and the same for everyone else? Yeah. I like the consistency of this.
Yes. Good. 15, 16, 17 are all pretty much the same. It's an application of the same idea. And 17, it ups the ante, it gets a little tricky, but then we learn an equation that makes it all pretty simple. Oh, that's why you were there? I was in your way. I apologize. Okay, this is absolutely a skill you have to be good at. Like 100% fact. This will be on the test. And that is finding Ka from pH or pH from Ka. So make sure you're with me. It says the pH of a 0.1 molar solution of formic acid at 25 C. And remember, we learned our lesson. Temperature changes the equilibrium expression, right? The values. We always have lesson. All right, the pH is 2.38. Calculate Ka for formic acid at this temperature. All right, so we know that Ka is equal to this stuff over that stuff, correct? Need a nice table for this.
Just backwards.
All right. Yeah, I don't know. I can't remember if we need a nice table for this. So I have the initial concentration. You all right with that? So we'll pretend we do. I swear we don't, but I'm just gonna call this H plus for that. If you're okay with that. Cool.
So
That was really stupid. But, oh well, who cares? All right, the initial is 0.1 molar. You okay with that? Then my H plus is 0. This is 0. Then at equilibrium, I will know my H plus. My H plus concentration, if I know the pH is 2.38, I can find the H plus concentration. It's equal to 10 raised to the negative pH, or the inverse log of negative pH. So will someone type in 10 raised to the negative 2.38? All right, 0 up.
041. 2 zeros. Oh wait, there's 2 zeros. 10042. Depending on how we.
That's even better. I kind of was hoping it'd be a really small number. Okay, so that would mean, I need to put my arrow here. This would be plus a number, this would be plus a number, and this would be minus a number, right? Their coefficients are all ones, correct? 1, 1, 1.
Then what happens to the other H? HCOOH goes to COO and 1H. What happens to?
It's H3O. You just wrote it as H plus because
Yeah,
why
but
not?
It's here.
Well, no.
There be
There's
other
two H's, H, COOH, and then all of a sudden there's like
Yeah,
dot.
this would be the OH right here.
Okay, so it's two.
It is cool.
Good call. I don't, usually they don't make mistakes like that before. I mean, I make a ton of mistakes. I'm not blaming them. This one is on me. Okay. Sorry. Okay, now they're all ones, so this would have been 0.0041. This would have been 0.0041, and this would have been 0.0041. So I know this number, 0.0041, and whatever this is 0.993. Point what? 0959? Yeah, I was even remotely close to my head. Okay, then what do we do with these values? Then we plug them in. So we would have basically 0.0041 squared, because I'm just multiplying those two, right? And I divide this by 0.0959. $1.75 times 10 to the negative 1, 2, 3, 4. Is that right? Is that what you guys got?
Yes.
Okay. Will someone do me a favor and type in this 0.0041 squared over 0.1? $1.68 times 10 to the negative 4. They're a little bit farther off than I thought. But we're going to learn pretty soon that for a weak acid, this change right here, come on, is almost unimportant. So it's 0.004. If this was a 1, it would be really, really useful. 0.1 is a little bit more important. But we're going to learn pretty soon that the change does not matter that much if it's a weak acid. Not sure if that's the next slide or not. But did that process make sense? We'll be given an initial concentration and a pH. We use the pH to find what the concentration of hydronium is at equilibrium, and then we just do the ice table. And remember how we came and like, how could we need an ice table? It's because Ka, okay. We're gonna just kind of simplify it. It's x squared over initial. But that's coming up probably next slide. Okay, so here is another example. This is a -9. This is times 10 to the negative. Okay. So this is a great question. I love this. I had a girl, her name was Annie Braithwaite. She's now a chemistry teacher. Well, now she's a mom. But she taught chemistry for 5 or 6 years. She was in one of my very first AP classes. And the morning of the AP test, she comes in and she's like, can we go over this question? It's on like HOBR, and I don't really understand it. Anyway, we went over Homer, and then she came after the AP test and she said, there was a question exactly like that. And it was this. So we reviewed that day, like it was so lucky. The exact question she was going to have. I mean, the math was different, but anyway, it is this question from those days. So hypobromous acid, or HOBR, is a weak acid that dissociates in water with yada, yada, yada. Calculate the value of H plus in a Homer solution that has a pH of 4.95. So there's no Ka or anything required for A, right? The H plus is equal to 10 raised to the negative pH. So that's all you got to do is just type that one in. So when we have 10 raised to the negative 4.95, we end up with that good right there?
Yeah.
All right, that's easy money. Like this question would have been worth 9 total points, not just these. There would have been C, D, F, whatever. There would have been more. It would have been 9 points. You would have got at least 1 right here. If you get 3, you're kind of all right. If you get 5, you're golden. So just 1 is easy right there. All right. Now, honestly, you would actually get 2 points on letter A, because you should have put Molar. So you would have got 1 point for the answer, 1 point for the correct. All right. So just there, 2/9 the way through. Letter B. Write the equilibrium constant expression for the ionization. You get a point for that. It should be H plus OBR minus over HOBR. That equals K. So you're up to 3 points.
We get points if we type that into our calculator correctly.
You get points if you get this answer right. Okay, so we get a point for that. And then it says, then calculate the concentration of HOBR. So we want this, right? If it has this as 1.8 times 10 to the negative 5. So we're just going to use this same thing. I know Ka, I know it. They gave it to me right here, right? So 2.3 times 10 to the negative 9 is equal to 1.8 times 10 to the negative 5. Now, I have a problem. Do I know OBR minus? Kind of. It doesn't tell me, but what do I know?
The concentration of H.
So concentrates in H, and they're the same value. They will always be the same value unless it was like H2 OBR. Then you have 2 and a 1, you have to apply this stoichiometry, but it doesn't. It's just a 1, 1, 1. Now, I don't know the denominator, right? This is just X. So take X over and then this under. So I end up with 1.8 times 10 to the negative 5th squared. And I'm going to divide that by 2.3 times 10 to the negative 9.
I got
It should be a decimal. Negative 9? That one can't be right.
0 plus add.
0.14 is much more accurate.
Yeah, 0.14.
It's okay. All right, my friends. Now, I'm not like a super genius. I don't even think I am, honestly. But like sometimes lately you said an exponent and I know it's not the right answer. Okay? The reason why is because I remember how exponents work. This is negative 10 overall, right? Because I'm squaring a negative 5. And this is a negative 9. So my answer should be a negative 1 decimal place. When you divide, you just subtract them. And that tells you the decimal places. Are you going to murder someone? Am I ever going to find a body?
That's what our data is gonna do.
Can I come along for your day? I don't even know what you guys are doing. I'll drive my minivan. Hello? Your days are freaked out. I got a chauffeur.
I'm
Tuesday
in the
Davis.
group. I want to come. Let's go.
Did you
We're gonna take pictures with you guys.
I'm there for you.
Show up in the jersey and
HFU. All right, are we okay with this?
Yeah, there are dance pictures where they take pictures of yesterday.
Now, here's my question. What's the unit on this?
There isn't one.
There is not one. It's just the equilibrium expression. It's unitless. Okay, how are we feeling so far? Good. All right, HF. There you go. Try this for the next couple minutes. Precious. Yeah, just pretend I'm like, oh crap, it's Morgan Freeman. My voice is Morgan Freeman instead. Okay. Okay, who can do A? Raise your hands. You can't do A, don't take the test. All right. It is these things. Now, I'll bet someone did it wrong. I hope not, but, and then just HF, no H2O, right? Because it's a liquid. All right, there you go. Okay, so we can do A, this. Calculate the molar concentration of H3O plus in the 0.4 molar HF solution, right? All right, so if we were to do an ice table, which we should technically do one and then do some algebra, but if no one got time for it. All right, we have, this is just HF, right?
Yeah.
Okay. All I know is this, correct? I know this is going to go down X. I'm sorry. So we knew this in 0.4, right? Sorry. So we know it goes down X. We know these go up X, correct? And so we would know that our ice table now is 0.4 minus X, X, and X, right? So we would know that Ka equals X squared over 0.4 minus X. You with me so far? I feel like we might be in trouble. I don't know if you have to, I don't know, let's just look at it. We have 7.2.
Make our lives easier and just pretend that. Never mind.
So X equals the square root of all that stuff, right?
There's an X on the other side, so we would have to like mix it up and be quadratic.
Right, who feels like doing that?
No.
Nobody does. Okay, so we don't. We make an assumption to make these problems easier, and it is fine. X for a weak acid is really small, right? The Ka is 10 times, or whatever, times 10 to the negative 4. So this is not a very large value, which means the denominator is not very large, which means that the subtractor from, sorry, the numerator, the thing we subtract from the initial is not very large. I'm just talking and just confusing people.
So
Just
in other words, we can
simplify
just
it.
ignore one of the X's.
Yeah, we say X squared, we don't ignore it. well, I guess we do down here, with x squared over 0.4, it would be minus x, so, but since x is so small, we ignore it, since nobody loves x. And then we can solve it pretty easily. So 7.2 times 10 to the negative 4 is equal to x squared over the initial, which is 0.4, right? So now multiply it by 0.4 and take the square root of it, and then you'd be ready.
Like, it doesn't actually really get it. That was the net.
And then you get 0.26, 0.016. Okay, and what is that value right there? It's the concentration of H3O. So you should put molar as the. Then there was a part C that I typed. What is the pH of the solution? So pH is equal to the negative log of H plus.
1.77.
Sounds good to me. Doable. All right, someone do the math where we have someone subtract this. What is that? What's that? 39928. Okay, then someone substitute that in right here. And see what we get. It's literally the same thing. It's off by thousands, right? And so if we change that, if we put it in here and we take the negative log of it, we're going to be like 1.7702 instead, or something like that. The change is so insignificant that we make this assumption. And it saves you guys a ton of math. Are we all right with that? Good. So what I want you to memorize on these problems is that the Ka for an acid can be generalized to be x squared over the initial concentration. And that x is equal to the H plus concentration. And that pH can be found by taking the negative log of x. No, that's when you find H plus from when you get it. So we okay with this kind of, let's just say a circle of math. It's three things. We're trying. These problems are on the AP test, and they're typically pretty simple if you remember the problem. Sometimes, like, you know how I said there's a bunch more letters? Letter F might say, explain why we were able to ignore the X or something in the first place. Say that weak acids dissociate to a very small extent, which means you don't have to include that. Okay, that was fun. All right, yeah, that we already did that. Here we go. Okay, let's try both of these. I think you can do that. All right, here we go. Are you ready? Hey, Brown reminded me of something I was eavesdropping in their conversation. if you went to choir 2 days ago, we were ready. Like, up there, we were gone. And then yesterday, there was 3 total, 4, 3 total people.
I was, oh.
So if you missed,
Attendance.
if you missed either one of the last 2 days, we didn't do it. So don't stress.
Why can't we do this more often?
Because the AP test is on like day number X, and we're approaching X quickly. Like, we can't just quit learning. The test is May 2nd or something like that. Yeah. So KA
2 weeks.
equals X squared over initial. All right. KA equals 10 raised to the negative 3.26. Why did I do that? Okay. Squared, right? Over 0.12. That's all you had to do. Or did I do it wrong? Is it what?
Yeah, that's what I got.
Okay. So what'd you get? Okay, these two, they went ahead and subtracted. And you did that too, and they thought they got it wrong, and then what was their math? It was the same answer. So were they righter? Yes. Were we all right?
Does it,
Yes.
if you are more correct, but you have the same answer as somebody who's less correct, does that?
You feel better inside, like you guys feel validated,
Do they feel more accomplished than us?
but yeah, then there's efficiency. Both were fine. Both were fine, and that illustrates why this works. Because it's such a small value. Okay, I'm gonna do this one the same way. I'm gonna take 10 to the negative 2.39. I'm gonna square it and put it over 0.128. Do you know why I'm putting 10 raised to the negative 2.39?
Yeah.
Except does not. Okay, this is how you find H. The H plus concentration is equal to the inverse log of the negative pH. And that gives me a number. That number is X, which eventually turns into X squared. So I was just shortcutting it. You probably did it right though, Steph. Didn't you? Okay. All right, so I was just writing it all out in one step. It's technically a 2-step process, but we can just do it in one. Okay, so 1 to 5, give us some feedback how you are on a question that gives you pH and an initial. I think some fingers. Okay, that's everyone I can see. I don't. Oh, okay, that's not too bad. I have no idea what's on the next slide. This is like surprise for Tom too. Oh, hold on. Oh.
No, I don't like that
Before we do
song.
anything, what is that company?
Yeah, can you tell us what it's called?
No.
I want to know what that is.
Type it in. It's some sort of acid. I have no idea what it is.
HC9H7O4.
Ask Google.
There's 10% odds I made it up. Just that.
Seriously, but only 10%?
Yeah. What do we have to do here that's different?
You have to figure out if there's. Except for there's one. Wait. Oh, you have to do the stoichiometry. Aspirin?
Okay. So this is the active ingredient in aspirin. It's called acetylsalicylic acid.
Oh, yes. Acetylsalicylic.
Acetylsalicylic acid. If it's aspirin, that's what that's called.
Acetylsalicylic acid?
Acetylsalicylic acid. I know I'm not square, so I gotta stop. Okay, look. We know Ka equals x squared over initial, what is the main difference? No one said it yet still. You have to find the initial when you're given grams, volume, and I saved you time by giving you electrolyte. Is it ironic that sugar and acetylsalicylic acid have the same molar mass and they both get you feel great? I did. If you take organic chemistry, you will make this stuff in the lab, but no, they won't let you do it.
We also make like pure caffeine.
And banana flavoring randomly. The whole lab smells like bananas that day.
Aspirin, caffeine,
Like
Banana or
banana. Yeah, so I think we should make.
I don't want that.
Banana flavored. Caffeine pills. And it's acid. I don't.
Is that more?
How would you feel about that? Did he say? Which part is not?
Well, so does 3.6 and I 20 is that equal?
That's the moles. And hey, everybody, this is done, but this isn't all you would do. If this was a tube, then we'd have to have this in parentheses over 2 as well. But since it was a 1, I can just go straight to moles, because moles molarity at the bottom is 1. How many agree with? Oh, crap. Who agrees with 3.15 times 10 to the negative 4?
Yeah.
Those are good answers.
I answered it before. Yep, I got that.
These.
I
I knew this was coming. All right. Oh, we've had this question sort of before. No, we were out of time. We'll start this tomorrow. We'll pay attention for a minute. Calculate the molar concentration of that in the solution. So we have grams. We have volume. You would have to find the molar mass, correct? Okay, now, we have had this question before. I believe it was on the review for the last test. Someone nailed it. I know we had this before. Does it seem familiar?
Yeah.
This part of this or that, which one is present in the solution at higher concentration? A or B? A, why, Delaney? Because it's a weak base. Weak base means lots. You know that? I swear we did this before. This isn't even like, there's no math on it. Maybe the DE error. Okay, have a good weekend. Next week, we're gonna learn a lot, so I hope we're sort of ready for it. We gotta end chapter 17 by the end of next week. 16 and 17 are the same text.